Tell me what you want to hear. Something out of like those years. I'm sick of all the insincere.
Without further ado, I would like to explain our first task of this project, which is data setting. Our dataset name is Autistic Spectrum Disorder ASD Screening Data for Adults. This chosen dataset is an open source dataset available from UCI Machine Learning Repository. This dataset consists of 704 instances and 21 attributes with missing values. The attribute is the mixture of 19 nominal attributes and 2 numeric attributes. Our dataset is more to medical, health, and social science. The problem we face with this dataset is to categorize the observation into has ASD and does not has ASD. So we decided to get rid as many as false as possible and try to fix the missing values to get 0%. In effort to successfully determine the best classification model for our data, we had done literature review from 2 academic articles. The first academic article with the title An Accessible and Efficient Autism Journal written by Hadih. This article provides the information on the efficiency of autism screening method for behavioral data and predictive analysis. In this article, the author proposed the ASD screening model using machine learning adaptation. While for the second academic articles with the title Analysis and Detection of Autistic Spectrum Disorder using Machine Learning Techniques with the authors which are Murad and Syafiq. This article offers the detection and analysis of autistic spectrum disorder using machine learning technique. It also provides additional information on using machine learning technique in medical health fields. As what have been studied from these 2 articles, the authors from both articles choose and propose to use machine learning to detect any problem related to autism. Some of them have used machine learning classifiers to detect autistic using imitation method. Therefore, there is a clear need to investigate the usage of deep learning-based models to detect ASD in human population. This can be related with our project, which required us to understand how Weka and attribute in the series of data works in order to get correct and precise data.
What is data cleaning? Data cleaning is the process of detecting and correcting corrupt or inaccurate records from a record set, table or database, and refers to identifying incomplete, incorrect, inaccurate or irrelevant parts of the data, and then replacing, modifying or deleting the dirty of course data. We have 21 attributes in our data. For the attribute study, the attribute were classified into 2 categories, which are numeric attribute and nominal attribute. For our dataset, we have 2 numeric attributes, and for nominal attribute, we have 19 attributes. For our dataset, we got 2 attributes with missing value, which are ethnicity attribute with 95 missing value and relation attribute with also 95 missing value. Then we start handling the missing value by opening the preprocess tab, choose filter, then unsupervised, select attribute, choose replacing missing value and click apply. After that, the missing value for both attributes becomes 0. For the next step in data cleaning, we have to handle noisy data and outliers data. Noisy data is useless data. It contains any data that machine cannot translate or understand properly, such as unstructured text. Then outliers explain about a piece of data or observation that divide drastically from the given norm or average of the set data. But in our cases, our data does not contain any noisy data and outliers data.
You may ask, what is data transformation? Okay, data transformation is the process of changing the format, structure, or value of data. Under data transformation, there are three types of data transformation, which is first is the data normalization, second is the data discretion, and last is data attribute construction. Okay, as per data set that our group utilizes, we uses the data normalization method only. What is data normalization method, you may ask? Data normalization method is the process of organizing the data in a database. This method includes by creating tables and allowing database becoming more flexible, which reduces the redundancy. Why, you ask? We want to reduce redundancy of data. This is because redundant data wastes this space and causes a maintenance problem. Okay, there are the steps of data normalization, which are reprocess, filter, unsupervised, attribute, normalize, click OK, and lastly is click apply. Okay, before undergo normalization for the attribute age, the minimum value is 17 and the maximum value is 383. Meanwhile, the mean is 26.698 and the standard deviation is 16.484. And the result attribute, the minimum value is 0, maximum value 10, mean 4.875, and the standard deviation is 2.501. Okay, after undergoing the process normalization, the minimum and maximum of both age and result attribute is 0 minimum and 1 for maximum value, and the scale is 1 and translation 0. Weka will read the range value between 0.0 to 1.0. Okay, data discretion is a method of converting attribute values of continuous data into a finite set of intervals with minimum data loss. Attributes construction is a type of data which pre-processing method. It consists of applying some data transformation operations to the original attributes.
Data reduction is a process that reduces the volume of original data and represent it in a much smaller volume. Data reduction technique ensure the integrity of the data while reducing the data. When they collect data from different data warehouse for analysis, it results in a huge amount of data. It is difficult for the data analyst to deal with this large volume of data, so it is even difficult to run the complex queries on this huge amount of data, as it takes a long time, or sometimes it even becomes impossible to track the desired data. So therefore, reducing data become important. Data reduction technique reduce the volume of data yet maintains the integrity of the data. Data reduction does not affect the result obtained from data mining. That means the result obtained from data mining before data reduction and after the data reduction is still the same or almost the same. The only difference occurs in the efficiency of the data mining. So data reduction increases the efficiency of the data mining. Predictive analytics is extracting patterns from the past data to develop informed guesses about future outcome. So, in data mining is a crucial step in the process of predictive analytics. It is used to extract information from the current data to predict trends. It aids the analytics team by finding the relevant data and use it in the predictive models to find what will happen later in the business. Weka is one of the most popular tools to make predictions on nominal or numeric quantities. The steps are: first, click on the Classify tab to start making prediction, and the second one is click on Choose button in the classifier box just below the classifier tab and select trees J48, and the last step is choose Test option to Test option panel.
As for our dataset, using classification method, we have run and test our dataset to cross-validation test with different fold, which is K10 and K20, and percentage split 70-30. The result for the test is as shown here. The correctly classified instances for the cross-validation test with fold 10 or K10 is 371, with the percentage of 52.6989%, and the incorrectly classified instances is 333, with the percentage of 47.3011%. The true positive value that we got from this test is 163, and true negative is 208. For the false negative is 174 and false positive is 159. The correctly classified instances for the cross-validation test with full 20 or K20 is 392, with the percentage of 55.6818%, and the incorrectly classified instances is 312, with the percentage of 44.3182%. The true positive value that we got from this test is 180, and true negative is 212. For the false negative is 157, and false positive is 155. The correctly classified instances for the percentage split test with 70% is 117, with the percentage of 55.4502%, and the incorrectly classified instances is 94, with the percentage of 44.5498%. The true positive value that we got from this test is 48, and true negative is 69. For the false negative is 57, and false positive is 37. The correctly classified instances for the percentage split test with 30% is 260, with the percentage of 52.7383%, and the incorrectly classified instances is 233, with the percentage of 47.2617%. The true positive value that we got from this test is 39, and true negative is 221. For the false negative is 203, and the false positive is 30. As can be seen from the tree view overhead, this is our tree visualization of our dataset that has undergone missing value removal and data normalization. This tree visualization looks complicated and difficult to read because we have not run our dataset through data reduction process still. After the data reduction, we run our dataset through cross-validation test with different fold, which is K10 and K20, and the percentage split 70-30. The result for the test is as shown here. The correctly classified instances for the cross-validation test with fold 10 is 386, with the percentage of 54.8295%, and the incorrectly classified instances is 318, with the percentage of 45.1705%. The true positive value that we got from this test is 64, and true negative is 322. For the false negative is 273, and false positive is 45. The correctly classified instances for the cross-validation test with fold 20 is 384, with the percentage of 54.5455%, and the incorrectly classified instances is 320, with the percentage of 45.4545%. The true positive value that we got from this test is 64 and true negative is 320. For the false negative is 273 and false positive is 47. The correctly classified instances for the percentage split test with 70% is 106 with the percentage of 50.237%, and the incorrectly classified instances is 105 with the percentage of 49.763%. The true positive value that we got from this test is 16 and true negative is 90. For the false negative is 89 and false positive is 16. The correctly classified instances for the percentage split test with 30% is 259 with the percentage of 52.5355%, and the incorrectly classified instances is 234 with the percentage of 47.4645%. The true positive value that we got from this test is 55 and true negative is 204. For the false negative is 107 and false positive is 4. As can be seen from the tree view over, this is our tree visualization from our dataset that has undergone data reduction, leaving it with 3 important attributes that help us achieve our objective of this study. The 3 attributes are autism attribute, jaundice attribute, and gender attribute, and all those 3 attributes are nominal attribute. Compared to the tree visualization before the data reduction, this one is seen very neat and comprehensible. As for the conclusion, we have made a percentage accuracy comparison for our original dataset and the dataset after the data reduction. As shown in the graph, the accuracy percentage of cross-validation tests with tenfold or K10 for original dataset is 51.42%, and for the reduced dataset is 54.83%. As for the 24 or K equal to 20, the accuracy percentage for original dataset is 54.55%, same goes to the reduced dataset. For the percentage split test 70%, the accuracy percentage for original dataset is 54.50%, while for the reduced dataset, the accuracy percentage is 50.24%. Percentage split test 30% shows the accuracy percentage for original dataset is 52.33% and reduced dataset is 54.54%.
Sometimes all I think about is you. Late nights in the middle of June.